Hello, sir. Hello, sir.
Hey, good morning. How you doing?
I'm fine, sir. How are you,
Good
sir?
job. I am good. Thanks for asking. How you stay with the differentiation now?
I'm good. I'm good.
Mm,
Honestly, the only problem the time was that I got the placement wrong. But since then, I remember now. So, fine. Everything else otherwise is
okay.
is, sir.
Yes. Tonight I want to go through the other rules, the quotient rule, and I want to be able to see if I can start some applications to differentiation today. So if you can get the past papers and find some question, you could scan it and put it in the chat. I'd appreciate it. So when others join, we can just go ahead and have it done. Oh, that's all.
Sounds fine, sir.
Okay.
Good evening.
Good afternoon.
Um, okay.
Evening, everyone.
Yeah. Um, all right. Like you already directed last earlier on at the start of the class. And towards the end of the class that we're going to be looking at the portion for today. Um,
Sir,
yes, sir.
your sound a bit metallic. I'm not hearing you quite good.
Okay, Damon, are you hearing me better now?
I
Yes, sir.
think it's still kind of low,
I think so.
All right, still low?
just a little. Not sure what's that.
Well,
Uh,
I can hear, sir. Fine, by my end.
okay, all right. Um, trying to sort out something for one of his students too. Oh, two. All right, so the the directive for our last class is that we are going to be looking at um, the other rule for this. Sorry, the other rule for differentiation, which is the quotient rule. And I'm a little worried, guys, if I were to be honest with you. Um, I'm a little behind. Well, I'm behind. I didn't expect to be on this for so long, to the point where I must start an application question today, or else I'm going to be in luck. Jesus, I can't even do that. Yeah, I have to start an application question today, or else I'm going to be in serious problems. Um, I'm still at unit 3. I'm finishing off unit 3, actually. Well, I finished unit 3 because I finished differentiation, but I'm still doing a review of it with you. And I have units 4, 5, 6, and 7 to do. Sorry, 4, 5, and 6. I have 3 units to complete. So I have to move into, I'm going to skip unit 4 for now, and then jump into unit 5. Yeah, and then when I jump into unit 5, and I feel comfortable with that, if I can start and finish unit 5 today, I'll be a little bit more relieved. And then we can focus on 4 and 6 thereafter. Also, yes, unit 7 is like a 30 minutes class, so I'm not even going to count that into it.
Sir,
All right. Yes, please, sir.
good afternoon, sir. I have a bit of a concern,
Mhm.
and that's for EducaSoft.
Yeah, and I'm going to say to you, if I'm the teacher and I said that you're not supposed to be concerned, I'm going to ask you to leave it.
Okay, sir.
Yeah, man. Just leave it. I'm the teacher and I'm saying, um, just leave it for now. We will be fine. I'm the teacher. Just trust me. If you don't trust me, it means that I'm not supposed to be here.
Okay, sir.
Yeah, man. Cool. All right, let me just check back this message to see if I got a response. No. All right, let me just project something here. I need to make a telephone call on behalf of a student. Just go ahead and share. All right, so the quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. If you can remember the rules and you know how to differentiate, there is no way you are supposed to be getting any other questions incorrectly. There is no way you're supposed to get any other questions incorrect. So let's just look at this example here that I have. I have this example that says the denominator, we're not call it a write it back, the denominator x minus 2, x plus 2, right here. And then I'm timesing that now by the differentiation of the numerator. So I have x squared, I'm going to differentiate x squared, I'm going to get 2x. Do you agree with that?
Yes, sir.
Good. So it's going to be times 2x. Minus the numerator, which is minus x squared. Minus the numerator is x squared minus the numerator. Times the differentiation of the denominator. When I differentiate x, I get 1. When I differentiate 2, I get 0. So this differentiation of the denominator is 1. So see, it's times 1. Can you see that?
Yes, sir.
All over the denominator square. All over the denominator square. So I'm going to have x plus 2 all squared. I'm not interested in expanding the denominator. I'm not interested in expanding the denominator. So I'm just going to do a little bit of rearranging. This 2x, I'm going to put it in front of this. See it right here, so? And then all of this can stay what it is just now. Let's just do the multiplication. Remember, the dots mean that you're multiplying, eh? So watch me now. 2x times x is 2x squared. 2x times 2 is 4x. And minus x squared times 1 is a minus x squared. Do you see that?
Yes, sir.
Good job. All I'm doing right here now is putting the like terms together. All I'm doing is simply to put the like terms together. I recognize that I have 2x squared minus x squared. So when I add those, I'm just going to get simple x squared. See here? X squared. And then I'm going to have my 4x because that stands alone. Remember, I am not interested in evaluating or expanding the denominator. Once I square that denominator, it's going to stay as is. I'm just going to be working out the numerator. This is supposed to remind you so much of first principles when I'm differentiating a quotient using first principles. Does that ring a bell with quotient first principles?
Yes, sir.
Right. And I did say to you, do not go ahead and do that. All right. And then now I recognize that I can factor out something. So when I factor out my x, I'm going to get x times x plus 4 all over x plus 2 all squared. So that now becomes my answer. Any questions?
No, sir.
All right. Oh, Kenneth, I'll talk to you afterwards. You here?
Okay, sir.
Even, sir.
All right, wait up, pops.
What I go on? I'll get back to me, sir.
Yeah, man. I'll talk to you afterwards, man.
All right.
Yeah, there was an impromptu timetable meeting that I did not remember. I can't tell you that I didn't know that it was on because when I checked my calendar, I saw it. But I actually went in on campus to do something else today and then got caught into that meeting, honestly. All right. But we'll talk afterwards, man.
All right.
Yeah, man, no problem. So if you really look at it, the quotient is really not difficult, The quotient rule is not. Matter of fact, none of the rules I can say is really difficult. When you go into an exam and you see the differentiation, you're supposed to jump up and down, literally, and laugh off at the people then. Because irrespective of how complex the differentiation may look, if you take it step by step, I guarantee you that you should be fine. All right, so that's one. Any question as it relates to this one?
No, sir.
All right, I'm going to give you this one to do on your own. Oh, Lord. I'm going to give you this one to do on your own. y is equal to x cubed. Nope. Y is equal to x squared minus 3 over x minus 7. I'm right here. I'm going to ask you to work the question quick and fast for me. And let us see how well you navigate this one. On your mark, get set and go.
Sir, could you scroll back to the rules so I can take a screenshot?
So I'm seeing in the chat privately, I'm seeing some responses. And to be honest with you, I don't like what I'm seeing. Hold on, something else just came in. Hold on. I'm checking this one. Sorry. I'm not seeing, I'm not seeing, I'm not seeing, I'm not seeing the responses that I want. All right, I'm gonna do this stuff. Um, All right. Dijon, I sent you a message. Please action it for me. Okay. All right. Taxter, you are like 99% right. Taxter, you are like 99% right. You make a mistake somewhere. What? What are you talking about? Okay, yes, sir. Thank you for correcting it. So you're correct. Locarno, you made the same mistake like Taxter. So you need to go and fix something, please. And Rayton, you make the same mistake like Taxter and Locarno. Go and fix it, please. The more I don't like the format that you sent it in. It's quite a bit. That's why I normally respond to you privately, but because it's quite a bit now and I want to get to the question, that's why I'm just talking it on.
So you want me to send it like how the blue one set out?
Just saying to you that TKLI, I don't like that format. All right, I'm gonna go. Andy, you see the message? Just answer yes or no. All right. All right. I don't like that. I don't like that. So a few of you, a number of you are giving me x squared minus 14x minus 3 over x minus 7 all squared. You have to be careful. You have to be careful. And I multiply these two negative numbers, I'm going to get a positive number. All you're doing is distributing this negative sign over the x squared alone. And then you're carrying back the 3 as being negative. Are you following me?
Yes, sir.
Yeah, man. So 1,
No,
2,
sir.
3.
Repeat that.
Again, sir.
I'm
Not again,
saying,
sir.
I'm saying to you what you've done, Lecarno, you use this negative 1 and multiply by the x squared to give you negative x squared. But you're not distributing this negative 1 over this negative 3 to give you a positive 3. So that's why you brought back the negative 3 down as the answer. Are you following what I'm saying, Lecarno?
No, sir.
When I multiply, but when this negative sign is outside here in front of a parenthesis, what do I do?
No, no, sir. Apprentice is supposed to do that, sir.
Rockstone, what do you mean? All right, let's go. Let's go. Come, guys. Come. I'm not going to.
Oh, because they're times by the 1, sir.
Yeah, basically. So you see in front of the x squared, the bracket x squared, the negative there, well, it'll be a takeaway sign from OYAC, but it'll actually be a negative one. Because remember, so you have the one in the bracket, so you'll just move the one there over to there, so and you can turn into a negative one. And you times it by the x squared, and you get basically negative 1x squared, but you can just put back. I sorry, say already, so negative 1x squared. And since a negative and times a negative is a positive, so you can times the negative 1 by the
Yeah,
negative.
yeah, mix me up more now or mix up right now. So.
Oh, that. All right.
That is mean. You can't say thank you, but you're not honest, and you just shut him down a while ago. Mean.
No,
It's
sir,
all
I
right.
go all over the place, sir, so I mix me up right now.
No, no,
Mean.
it's
All right.
literally.
Never mind here, Damoy. I appreciate. I was following Damoy, but never mind. I will take over. Thanks here, Damoy. Hey boy, just be nice. All right, let's go. So we have y is equals to x squared minus 3 over x minus 7. Once you see something with a numerator and a denominator, and they check again, numerator and denominator, it means that we're talking about the quotient. Quotient. Quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. The denominator, see it here, boom, I write it back, times the differentiation of the numerator. When I'm times in something, I'm going to put in a parenthesis. So it's going to be times the differentiation of the numerator. When I differentiate the numerator, differential of negative 3 is 0. Differential of x squared is 2x. See the 2x here. Minus the numerator, I have multiple terms. Once I have multiple terms, it must go into parentheses. Once I have multiple terms, it must be placed in parentheses. So minus the numerator, so it's 9. You see it now, good. But that's why I said the same thing too, but never mind. Let me just finish up. Because I want you to.
Where you were explaining, sir.
All right, no problem, Papa. Taxter, I want you to look at this, Papa. So times now the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1. So look at the mistake that I'm figuring that about 4 or so of you were making. The first part was fine. X times 2x is 2x squared. Can't blame me for that. And then negative 7 times 2x, you can get negative 14x. Perfect. But what I'm seeing you guys are doing is using this negative 1 to multiply this x squared to give you negative x squared. Very good. But you're not using this one to distribute over this negative 3 to give you positive 3. So what most of you did, but 4 or 5 of you did, was to carry back this negative 3. It's really not a negative 3 that you're carrying back. You're multiplying this negative sign by this negative 3 to give you a positive 3. Tax, you see that, Pops?
Yes, sir.
All right, good. And then now you'd have everything here. You're combining 2x squared minus x squared is going to be a simple x squared. And negative 14x is a standalone, and a positive 3 is a standalone, all over the x minus 7 all squared. Let me tell you where I'm concerned.
Sir,
By the way, sir, I just let you know, so I realize I'm not doing it correctly. To hear before you
All right. All right, good.
so I have the line right above that red writing that we have. Exactly that. No, I can't exactly that. I'm still get it wrong. I have a -1 instead of the ×1 where you have another bracket. I think I did some error start.
Yeah. It would be.
All right, sir, proceed.
Mm-hmm. Andy, when I send a message again, it's like about 3 times that I send a message, honestly. 3 times I send it. Never mind. All right. Any question as it relates to this?
I'll give our next one.
Oh yeah, absolutely. 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 All right, so I'm giving you this one here. Look at the bottom of the screen. Y equals x minus 3 all squared over x squared minus 7. Try that for me, please. Y equals x minus 3 all squared over x squared minus 7. as soon as you finish, you can start dropping your responses in the chat. Kristen, I need to hear from you tonight here, my love. I'm not leaving you on the roadside. So you need to find something and talk to me about in class tonight. Thank you.
I'm still on my way home, sir.
Oh, okay, got you.
So we get some feedback on that one, there, sir. Think
I'm looking at I'm looking
still.
at I'm looking at it as we speak. Um, email sent Andy. Ask the student to check for me, please. Checking this one here as we speak. Oh, sorry, that's not what I'm supposed to be looking at. Oh Lord. Um, oh. Mm. All right, so for the pair of you that sent me the stuff, the denominator is correct. Wait. Well, Mason, your denominator is correct. The one that came before. Yeah, the one that came before. You left off something in the parenthesis for the denominator. Maybe a typo, maybe you have it in your book, but something is left off. But the numerator for both of them that I've received so far are incorrect. The numerators are incorrect. What is, I don't, it may not teach a topic right. I don't know.
So you're talking my own, right, sir?
Yeah, me never want to call the name. Lord, they couldn't just make it be anonymous. Sure.
No, sir, me need to know if it's wrong.
But I'm you know it's you me talking to, so we never.
Sir, I don't know how many people send it.
Yes, sir. You. I did say for the two of them that I received, and I spoke about Ninja, so that means the other one. You know, he sent me something, but anyway, don't worry about it. Since you have so identified yourself, sir, TDR. Yeah. They left off something in the parentheses for the denominator. I'm nervous, guys. You if I were to be honest with you, you guys are getting me very nervous.
Sir,
There's something.
We keep missing something. I'm trying to wonder why.
Yes, that's the thing, and because of that, I'm very nervous. I'm wondering what it is that I've not done with this group that I have done with the other groups that they are able to catch it. All right. Let me just see. One more, just kidding. Let me just check this one. Okay, so there is nothing wrong with me. Big up yourself, Damoy. Big up your good self, Damoy, because you get the question right. Me proud of you. So it's not me then. It's not me. Very good, Damoy. Let me see if it is correct to the T. Budov, yes, you are correct to the T, Senor. Very good. Bueno. All right, let me just, let me share. I'm going to go through the question. I'm going to ask you to look at the question for me, please. I prefer if you don't write. I prefer if you don't write. I can press pause when I'm finished so that you can write off the stuff. I just want to see. I want to go through the question with you. All right. The question says y equal x minus 3 all squared over x squared x squared minus 7. All right, x squared as well. X squared minus 7. So my differentiation is in blue. Here goes. The denominator, x squared minus 7, times the differentiation of the numerator. I am differentiating the numerator, but you now recognize that the numerator is of what form?
The power rule. I didn't apply the power
rule. Power rule. Power rule. So watch me. So it's going to be 2, boom, right here. X minus 3, and you subtract 1 from the power, times the differentiation of what is on the inside of the parentheses. I'm pressing pause so that you can see that one. Everybody see that?
Yes, sir.
All right, no. Minus the numerator, numerator is x minus 3 all squared, x minus 3 all squared. I'll call it, I write it back. And then now I'm timesing it by the differentiation of the denominator. I'm timesing it by the differentiation of the denominator. When I differentiate -7, I get 0. But when I differentiate x squared, I'm going to get 2x theta times by 2x all over the denominator squared, all over x minus 7, x squared minus 7, all squared. So it's a denominator right here, so times the differentiation of the numerator, but I recognize the numerator as power rule, so I have to use a power rule to get this one here. It's because inside of the parentheses is only x. If you forgot that it was a power rule, you would have gotten away with it because you're only multiplying by 1. You'd have gotten away with it. Minus numerator, which is x minus 3 all squared, times the differentiation of the denominator, all over the denominator squared. And then now, we're going to try to fix up. I'm never interested, just like when I'm doing it, the first principles, I'm never interested in working out what the denominator is going to be like. Not interested. So we're going to work with the numerator. It's x squared. Ooh, I'm going to fix it up first. This 2 times this 1 is this 2. This x squared minus 7 is this, and this x minus 3 is this. And then I'm just putting the 2x in front of here to get this, and then write the x minus 3 all squared right here. So this line here could be a wasted line. It's the same line as this. I'm just rearranging. One of the things that I try to show you here is to recall something for you, that x minus 3 all squared is going to be x minus 3 times x minus 3, which is the same thing as x times x is x squared. X times -3 is -3x plus 3 times x is 3x. Hold on 1 minute, please. 1 minute, please, guys. And hold on. All right, sorry guys, I'm just trying to resolve a matter for a classmate, and it's yeah, sorry about that. All right, so I was saying to you know that I did this because I kind of figure that some of you can recognize, will not recognize that when you're expanding x minus 3 times x minus 3, so when you give you x minus 3, it's going to give you x minus 3 or minus 3x minus 3x, which is minus 6x. So lots of you do the expansion here and leave out the middle term. So that's what I was trying to do, is to remind you that there is a middle term, and the middle term is negative 6x, right? Plus 9. And then now what I'm going to do is just to make the substitution here, the x squared minus 6x plus 9 for this x minus 3 all squared. So this is going to be 2, which is here. Watch me. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. With me so far?
Yes, sir.
All right. Negative 7 times x is negative 7x. And negative 7 times a negative 3 is a positive 21. Minus this 2x is the same 2x here. And this x minus 3 all squared is what I would have done here. And I am substituting here. So what I'm doing now is to say 2 times x cubed is 2x cubed. 2 times negative 3x squared is negative 6x squared. 2 times a negative 7x is a negative 14x. And 2 times 21 is 42. 2x times x squared is 2x cubed right here. So I notice I'm still keeping it in the parentheses because I'm not yet distributing a negative sign. So the negative sign here is in front of the parentheses. I put it back. 2x times negative 6x, 2 times negative 6 is negative 12. So it's going to be negative 12x squared. And 2x times a positive 9 is going to give me 18x. Now I'm going to distribute a negative sign. All of this, I'm writing back all of here. And it's negative times 2x cubed is a negative 2x cubed. This negative 1 times a negative 12x is a positive 12x. And that's a positive 12x squared. And this negative 1 times this positive 18x is going to be a negative 18x. Then I'm looking for like terms. You see that I'm canceling out this 2x cubed. Positive 2x cubed cancels out with a negative 2x cubed. So I'm going to be left with negative 6x squared. Lie. Because negative 6x squared plus a 12x squared giving me a positive 6x squared, which is right here. And negative 14x minus a 18x is going to be negative 32x. See it right here. And then I'm going to have the 42 as a standalone. See it right here. Notice, from my catch up here, so I have my x squared minus 7 all squared. See it here again, and again, and again, yet again, and it's finally here. I'm not interested in working out what the denominator is. Never get into the habit of not trying to. It's not going to take you anywhere. Simply work with the numerator. If anything can cancel out with the denominator, it will show itself up. It will show itself up. Otherwise, still take business. Are you with me right here now? Are you okay?
One more, sir. One more question.
Yeah. To be honest with you, I'm not even so convinced that you guys are really there with me,
No, I mean,
Sir,
as in, I want to.
sir,
I want.
them there, sir. Some people just kind of
No,
confused.
but don't
No,
no.
man,
Sir?
teacher. I understand what you're saying, as Papa. I understand what you're saying, man. But I'm just saying, I'm not even sure if the other students are with me.
That's why I said I want to try one more question to test myself to see if I grasp it. Then I can say yeah or nay. Because I hear what you're saying, and I'm reworking the question at the same time without looking at the answer on the board, and I'm getting it, but I'm not sure if it's sticking. You get where I'm coming from, sir?
No, man, I'm right where you are, Papa. I'm actually trying to find a question here for you, so I'm right where you are. It's just that I wouldn't mind if I could hear from the other students in the class as well, but all right. I have there, okay. I have a question 9 that I just generate here, so that I'm gonna ask you to do. Differentiate for me, please. F of x is equals to 5x squared plus 7 over 6x minus 2.
5x squared plus 7 over 6x what now, sir?
6x minus 2. It's at the bottom of the page on the screen.
Oh, okay. All right, so let me go ahead and try that. Sir, check the message I just sent.
All right, I'm checking. I will tell you in a few. Give me half a second.
No problem.
Um, All righty. Yeah, this looks like you have finally gotten it. I
Thank
am proud of you. And Andrew, you're right to Andrew.
Where's the sir? Am I right?
Why you sound so surprised, Andrew?
Yeah, tell him, sir. We just
Uh,
reached it. I was traveling.
yeah, man. It's correct. Very nice. I give the rest of you 2 more minutes to complete this up. I am moving into a new topic. You know what you do for me? I need somebody to find a past paper. Find a past paper. We're going to shut off a few questions. I want a past paper that gives you a bit of mix up differentiations, product rule, chain rule, quotient rule, power rule, and then we just run off those. It's now 6:34. By 7 o'clock for sure, I must start that new topic, or else we're going to be in problem. So the rest of you are working. So Andrew and Richard, since you guys finish your question, you will look for the past paper questions, please. 2 more minutes.
Look through the past paper or look for the past paper, sir.
Yeah, man. Look for a past paper question that has a series of the differentiation questions on it, and we can just work those past papers in class now. But at 7 o'clock, you hear old time people say, wait, Margaret Pop. At 7 o'clock, I'm stopping because I'm starting a new topic.
Okay.
All right, cool.
Sir, could you check the chat, please?
You are also very correct, Kahim. Me notice you're not talking to class tonight, like you vex with the world. But very nice,
For
Papa.
me?
Yes, sir. Me not hear from
I did
night
speak in
start.
class.
Me not hear from evening start. But
Sure,
very
that's
good
not
though,
true.
Papa. Very good though. You're correct. To the T. Very nice.
All right, sir.
So you can help them look for the past paper question here.
Yes.
Cool. The rest of you, please come on, hurry up.
Sure, I sent mine.
Come to the Wi-Fi. I never get it, Miss Remy. I left the class.
Hmm?
I don't have
Hey, me, Mike.
All right, Ken, you, all right, you're making me feel very proud now, guys. Lecarno, big up yourself. I am proud of you. All right, guys, I'm feeling relieved. All the responses that I've gotten so far are correct. I am
Every one more question before register thing. You have still in a service. We had a concrete. So you see when you do after you drill you have to drill the hole first and then you put in the screw to make it hook.
Yeah, man, but guess what? No, that's why you're gonna find the question then for me now, you know. Are you me away pan now, you know, because the answers them are coming. You notice I don't post anything yet. The answers them are coming. Kenneth, Lecarno, Hamilton, McLean, Smith, Richards. Yeah, man, they answer them right. So come on. So find the question, please, and just if you can screenshot it and just put it in the you'd have to send the whole paper. Just screenshot it and put it in the chat for me. I can copy it and put it on the stuff and we just work the questions together. Or I can give you to work and then I then get thereafter. Whichever one that makes it easier. Let me see if I can find. And if you can't find anything, but you don't know what happened now. Tell you what happened now. It's like when I spend so much time on the money. I bet you're not gonna forget the product pool. All right, guess what? All right, good. All right. I was just about to say, guess what? Let us not. Me never did ask the first time one wicked question. The coroner. No, how you gonna go with this? Jesus. Look on number 3. Wow. Whew. All right.
Yeah, me never sure. If I when I question them, nothing, we just
Yeah,
see
man.
something
It
to
says
differentiate.
differentiate. Yeah, man. You're right. But how many marks of question one, Nakano?
One of them, each of them value 5, sir.
No, sir. Them can't give question 3 for 5 marks.
That's
Mm.
a five, I say.
And then can't give question 3 for 5 marks. All right. Guess what? So we're gonna wrap up the session with these questions. I'm gonna. All right. Thank you, Papa. I'm gonna. Oh, come on. I just. Where's that? All right. I'm trying to find a new page. My control N is not working clearly. Let me go again. Okay. There you go. Paste. And I'm trying to get me. All right. Remember, when 7 o'clock coming, I'm stopping because I cannot use a whole session to just do this. I'm going to be in problems. I'm so happy that we can make up by doing some questions in the week, so we can make up some lost times. All right, new share. All right, tell me that you're seeing my screen, please. Are you? No? Are you no?
Yes, sir.
Yes,
All
sir.
right.
Say my data done.
I don't know if it's finish, but I was hearing you though, so it now finish. Come I hear you. All right. So I have 3 questions on. We have 15 minutes. We're going to use 5 minutes per question. On your mark, get set, go. On your mark, get set, go. I don't want anybody to just sit in class and not do anything. That's not nice. You know what I finish question 1? X plus 2, X plus 1, X plus 2, X plus 1. All right. Okay, Ashantio, very good. I like the look of that one. Move on quick and fast for me, please. Very nice. The rest of you, talk to me no man. Cheer. Carno, we're not hearing from you. What is wrong?
Tutorial for how to get an emergency.
What was it?
An emergency, sir. Tutorial for how to get.
Oh, okay. Three x minus 2, 6x minus 3x minus 2, 6x minus 8, 3x minus 2.
Sir, the question of specifically asks for first principles for you to use first principles, right?
Hi, sir. Yes,
Okay.
please. Yeah, man.
Just
All
want
right. Yeah, man. Kahim, Andrew, Rayton, Demoy, Kenneth, you're all correct. Ashanti, yeah. All right. I like the second answer. Um, there is something, yes, Taj. Well, yes, Taj, you're good, man. I like, okay, Kahim, yes, your second one, Kahim, is fully right. Big up yourself. Oh, you ready to talk to me now? Ashanti, one little incident is something we have on a one there. I want you to fix it for me. One little incident is something. One little incident is something. Yeah, that's it. You're good now, Shanti. But make sure say it's not a guess. Make you just take up that incident or something and you know why it's not supposed to be there. So you're correct with the second one now. Hey, me want to see you and Kahim match up number 3. Oh, I need to charge. Hold up, hold up, hold up. I need to charge. Where's this light? Just wanna see. For some reason, I don't know why this thing. Okay, let's see. All right, there's no charger. Hold on, guys. Stepping away with a few. This computer's gonna go dead on me. Ah, oopsie daisy.
Sir, I'm about to send the last one.
Please and thanks. I don't need it doing it because God will do. All right, give me a minute. I'm just gonna pick me some water. Half a second, please. Just one second. All right, so we're on there now.
For number three, sir, that's minus -2 or just -2?
No, hold on.
I think it's minus.
3x minus 2.
Okay, okay.
Mhm. All right. So I'm going to match. I'm going to match. All right, Kahim, you are a little ahead of me because I went in search of my charger, so I didn't do number 3. So you're a little ahead of me, Kahim, but I'm going to do it. I'm just responding to the other messages. All right. Just make sure you get it right, because he said a threat. I don't take it lightly, So make sure it's right, All right. Because I'll take yours times 2 or 3 or 4. They can't make them both statement there and then after that I go say I take it back. It's crazy. All right. All right. So Ashanti gave me an answer also for number 3. The pair of you have the same answer for the denominator. No, actually, no. Nope. 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 2 different answers. All right, let me just work the question now. Oh, I actually started. Let me finish the question now. Okay. One person is saying, sir, my answer right. I'll let you know. I'll let you know in a few. All right, so this is this all right, 7 o'clock gone in, but this because I don't do this question. That's why I am not because I'm serious about moving on the web by DX.
Sorry, sir. You can reshare your screen, sir. It's saying for me, let me say it's the black. It's black.
All right, I come in. I can't reshare it yet because I paused it to work the question out. Give me half a second more, please, for the denominator squares. So while you're working, I am working as well. Square, square. Reduce. All right. No, I can understand if you don't get number. I won't be disappointed if you don't get number 3 right. From a side, do I know that it was a little bit more than what you're bargaining for the extra question as you asked for. All right, 2 more lines and then I'm finished. All right. Your denominator though is correct, Ashanti. What? I'm gonna just check what the numerator is. Hold on. 236, 53.
Sir, this feels a bit strange to ask you, but are you done? I want to know if I'm sexy.
No, this is what when old time people say liberty come through carelessness. You are just rubbing it into my face that I am finished all along and you are not finished yet. That's what you're saying, boy.
No, sir, I really want to know if I'm right or wrong.
No, Kahim, you've said it loud and clear, and everybody hear you.
Sir, I could have asked you if I'm right, but I didn't want to ask you, and then
Kahim, the damage is already done. You can't wiggle yourself out of the one, Papa. All right, I'm finished now, sir. If you want to know, Papa, finish now. All right. Okay, Ashanti, I'm convinced that you are the correct one. Very good, my love.
I have one question about number 3. Do we have to use the I call it fraction rule. I don't remember if that's the correct rule.
Quotient.
The quotient rule. The quotient rule.
Mm-hmm.
Do we have to
I'm
use
sure about my answer number 2 in the books.
we
Yeah, I
have to
think
use
so.
Okay. 3, 4, 6, 3, 2, 6. All right. Okay. I see what you did right there, Ashanti. But okay. Okay. I see what you did right there. All right. I see what you did right there.
So I can check my answer because
I'm checking. But which one is this one? That's number 2, right?
yes, sir.
All right, let me work up there. I'm going to share my document in a few. Kahim, just please. All right, there's something I should be. There's something suspect, Carnal.
In the right, sir.
There's something I can suspect about it. All right. I'm going to share. I'm going to share. All right. So what I'm happy about. Let me just make something. Oh, first things first. Already, I'm a bit concerned about 1 or 2 of my students in the class because the level of participation is almost non-existent. And I know exactly what has happened. You miss something, and because you miss it, it throws you off. You can't find back your rhythm, and because your rhythm is off, you are lost. There is hope of you coming back on stream. All I'm asking to do is just to review the stuff. I'm starting a new topic tonight. Make sure that you catch the new topic so that you have one less thing to worry about. The other thing is, some of you are getting now frustrated because the work is getting a little harder, and I agree. When I project number 3 to you, you're gonna have, you're gonna squeal.
Nothing like that, sir.
Say it again,
Lies.
Pops.
I said nothing like that.
Nothing like that? Well,
Nothing like that. No squealing around here, sir.
why? What's squealing? I mean, say something.
Don't entertain Kenneth. Leave Kenneth alone. Leave him
Oh,
alone.
okay. But me no know, but educate me. When me say squeal, is
Oh,
it wrong to me say?
Sir, Kenneth have crasses, sir, please. I'm Make me figure out how number three go, cause that said me if you
Stay away, so you see you Kenneth? Sure. All right. Yeah, but on a serious note though, guys, I really want you to just take it easy. I know it's getting a little bit rougher. Just take it easy, please. All right, let's go. Kenneth, you make your friend them figure you out, man. You can't trick your teacher and you get caught, Kenneth. All right, let's go. So are you okay? Well, everybody's okay with number one, don't it?
Yes, sir.
Yes, sir.
Is there
Yes, sir.
is there anyone in the class that has a difficulty with number one? Don't watch no face. Nobody can tell you, say, Jesus, you not get number one right. It's me alone must say it. Is everybody okay with number one?
I had to
Yes,
go and
sir.
look.
I made a
Yes.
small, made a small mistake with the algebra, but I see where I went wrong. Right? So yeah, I think I understand.
Love your honesty. Somebody else was coming in?
Yes, sir. I had to go and look up at the rule to remember how the layout go. To
And
remember which
that's exactly what I was saying. It's because we're doing so many more questions now on the quotient rule. I say, I bet them forget the product rule. But okay, fine. Numero dos, x plus 2 over x plus 1 all square. Now, when you look at that now, it's the denominator. Oh, so you notice none of them don't tell you not about no y. Them just give the function and say that. You notice what I said? Let y equal. So just like how some of you may not respond to youth, brethren, that you say, oh, never name. And what if you go call to one pretty girl and you go look on her and say it again?
would it have to write the let y equal
Yes,
that?
yes, sir. It's a language and we need to communicate. So just like how you want somebody to call you by your name, you have to call the function by your name, right? So I say let y be equal to that. In this case, I say let y equals this again. You could let f of x also or g of x, but you have to put a name, right? I won't penalize you now, but you have to have an address. All right, let's go. The denominator, x plus 1 all squared, times the differentiation of the numerator. When I differentiate the numerator, I get 1. C2 times 1. Minus the numerator is x plus 2. This times the differentiation of the denominator. I'm differentiating the denominator. It's a power rule. So let's go. 2 in front, C tier, times x plus 1 to the first, C tier. And then now I must differentiate what is inside the parentheses. And when I do that, I'm going to get 1 all over the denominator squares. Now, hear what some students will say to me, sir, I don't have to square it because it's already squared. Lies. It says all over the denominator squares. It never said all over the denominator squares, and if it's square, now square it again. Never said that. All over the denominator squares. So it is going to be x plus 1 squared, squared. And that is going to give you x plus 1 squared. Let me just put this recall right here. Oh, there's something I need to say to you guys here. Recall a to the m raised to the nth power is going to be equal to a to the mn. So when you have something raised to a power, which in turn is raised to another power, you have to multiply both powers.
Sir, can I
So
scroll
this can who?
just a little bit? Scroll up just a little teeny bit.
No, man. So each of those powers will be multiplied together to give you the new power. All right, students, make sure that while we are working the questions in class, that you guys are not going to Mr. AI. I have no problem if you use AI for classwork, but if you're going to Mr. AI, I can't see you. I can only encourage you not to do so. If you go to Mr. AI and you're spitting out these responses, I'm going to leave the session and my recording can support me when I say, congratulations, you've gotten correct. When the tire meets the road and you're going at the exam, I don't have AI on the corner dark. So let me know that you are understanding how to do the question without any assistance, so that when you're going to the exam, you are better off. Just saying that. Moving on. So I'm fixing it up now. So this x plus 1 all squares is this x plus 1 all squares. And this is going to be 2 times x plus 1 times x plus 2. I just fix up this one here. 2 times x plus 1 times x plus 2. Right. Watch me what I did right here. I didn't expand. Watch what I did. I looked at
Sir.
this term. You.
What if I expand it, sir? Would that be easier?
No, this method that I'm showing is easier.
Okay.
Yeah. So when you get to this stage, always look to see if there's anything common between the terms that we can go ahead and factor out. And especially if what it is that we can factor out can be divided by a term in the denominator. So x plus 1 all squared minus 2 times x plus 1 times x minus 2, x plus 2. I recognize that x plus 1 is common here and x plus 1 is common here. So I can factor out the x plus 1. When I factor out the x plus 1, I'm going to have one more x plus 1 left because the square I have here. So this is the other x plus 1 that I'm going to have left when I factor out one of the x plus 1. Remember, that x plus 1 all squares is the same thing as x plus 1 times x plus 1. So if I take out one of the x plus 1, I'm going to have one more x plus 1 left. And since I took out the x plus 1, that means I'm going to remove this x plus 1. So I'm just going to have minus 2 times x plus 2. See it here, sir? Minus 2 times x plus 2. I'll put this in red so that you can see. Now that I recognize that the same numerator is the same denominator, I can cancel one of this into one of this. So you know this was 4, it now becomes 3. So look at what I'm going to do now. I am now...
Sir, hold on, sir. Sir, what did you do on the x plus 1?
This one here, it cancels into one of this x plus 1.
No, the one beside the 2, sir.
This?
The one above. Yes, sir.
It's factored out. See here, I'm factoring out. This x plus 1 is common to this term and to this term. So I'm factoring out the x plus 1. So when I distribute this x plus 1 over this, x plus 1 times x plus 1 is x plus 1 all squared. X plus 1 times negative 2 times x plus 2 is going to be negative 2 times this x plus 1 times this x plus 2. See it here?
Okay, sir.
Come on, cool. All right, now, so, where am I? Okay, so I'm canceling out one of these. I'm canceling out this one with one of these down here. Then I'm going to be left with x plus 1 minus 2 times x plus 2. X plus 1 is this x plus 1 right here. Minus 2 times x is minus 2x right here. Minus 2 times positive 2 is minus 4. All over x plus 1 to the third power now. All of that is now raised to the third power because I canceled out one of them. X minus 2x is a negative x. 1 minus 4 is a negative 3. And all of that is over my x plus 1 to the third power. I could leave this as my answer, or if I want, I could factor it up. And because the negative signs are common, I can factor out the negative 1 and call it negative, open bracket, x plus 3 over x plus 1 to the third power. Now, guess what? Whichever of the two methods you give me, I would have given you full marks. I'd have given you full marks. Are we okay there?
Yes.
Where's the more? Where's Logan? Logan not here? Where's the more? Internet problem?
Sir, so is it that any rule you use, they get the same answer? Because I use the quotient rule.
The quotient rule? That's what I used to.
That's why you just said the product rule.
For what? For number 2?
Yeah, that's what you said.
No, ma'am. If I said that, I apologize, but it can't be the product rule. Well, it can be the product rule. I can show you that, but I didn't use the product rule for this. It's really the quotient rule. But yeah, it's a quotient rule. All right. Let us look at number 3. Jesus, 721. Number 3, again, they only give me the function. So I'm letting y be equal to the function. All right. Watch me. So I'm going to rewrite the function. You see, it has 3x minus 2 over 6x minus 8, all raised to the second power. Is the same thing as raising the numerator to the second power and raising the denominator to the second power. It is the same thing as raising the numerator to the second power and the denominator to the second power. Same thing. So I'm just breaking it up. Now I have my good quotient rule set up nicely for you. All right. Going to the quotient rule, the denominator, 6x minus 8 to the second power, times the differentiation of the numerator.
So
Press pause.
Yes, that's later. I'll tell us about that later.
Go ahead.
No, so you're pausing. So let me just write that.
I can go now?
Yes, sir. You can go forward. Well, for
Yes,
me,
sir.
and for anyone else.
Okay. Anybody else? I can move on.
Yes,
Yes,
sir.
sir.
All right, cool.
Yes, sir. I can move on, sir.
All right. So it's a denominator. See it here. Times the differentiation of the numerator. It's a power rule. So it's going to be 2. See it here. Times 3x minus 2 to the first power. See it here. Times the differential of the inside of the parentheses, which is 3. See it here. Minus the numerator, minus 3x minus 2 to the second power. See it here, sir. Times the differentiation of the denominator. Differentiating the denominator is going to be 2. See it here, sir. Times 6x minus 8 to the first. See it here, sir. Times the differentiation of the inside, which is going to be 6. See it right here. all over the denominator squares. 6x minus 8 squares, square. Remember, even though it is already square, you still have to square it again. All right? Then let me work on the denominator first. 6x minus 8 squared is 6x minus 8 to the 4th power. All right? Now, I'm going to fix up here. Look at how I'm fixing it up. 2 times 3 is 6. And then I write about my 6x minus 8 to the 2nd power. And then I write about my 3x minus 2 to the 1st power. 2 times 6 is 12. I put my 12 here in front. Then my 3x minus 2 to the 2nd power. And then my 6x minus 8 right here. Now, I'm recognizing, I'm not expanding out anything. Don't be too jumpy to go and expand out the numerator now. Look for similarities, and that's a trick. Look for similarities. When I look over here, I recognize the first things first, that 6 is a factor of itself and it is of 12. So I can factor out a 6, see here? Why, sir? Because 6 is a factor of 6 and 6 is a factor of 12. Watch me now. 6x minus 8 to the 2nd power, 6x minus 8 to the 1st power. I can take out the lower of the two, which is 6x minus 8. See it right here, sir? But when I also look, I see that I have 3x minus 2 on this side, and I have 3x minus 2 to the 2nd power on the other side. So it means that I can factor out a 3x minus 2. See it right here, sir? So these are my factors. So once I have my factors, then I'm going to close my parentheses, and then I look for my difference. Watch how I'm going to find the difference. I'm looking at this side and this side alike. But on this side, I have the 6 already. I don't need to put back the 6. I have 6x minus 8 to the 1st, but I have 6x minus 8 to the 2nd. So it means that I need one more 6x minus 8 in here. So that's why I put the 6x minus 8 here. See this 3x minus 2? I have it right here. So it's only 6x minus 8 that was missing. I put my negative sign. I have 12, but I have 6 here. What do I multiply by 6 to give 12? It has to be 2. So that's why this 2 is here. And I'm going to go back here. I have 6x minus 8. I already have the 6x minus 8 over here. But this one, no, I have 3x minus 2. But I have 3x minus 2 to the 2nd power. So I'm going to need one more 3x minus 2. So this negative 2 is going to be multiplied by this 3x minus 2. I also recognized that the 6x minus 8, my denominator is 6x minus 8. But I have a 6x minus 8 here. So I can simplify my calculation and divide one of this 6x minus 8 into one of this 6x minus 8. Since it's to the 4th power now, I'm going to have it to the 3rd power. So this 6 is this 6. I no longer have a 6x minus 8 in the numerator, but I have a 3x minus 2. See here, 3x minus 2. So where you get this minus 4 from? All right, let us check. Negative 2 times 3x is negative 6x. See it right here, sir? And negative 2 times negative 2 is a positive 4. See it right here, sir? And then this positive 6x cancels out with this negative 6x. So I'm only left with now negative 8 plus 4. And negative 8 plus 4 is going to be negative 4. And that's why I have this negative 4 right here. And then I put back everything over my 6x minus 8 to the 3rd right here. And then I recognize that, I can multiply the negative 4 by the 6. And 6 4s are 24. So I'm just going to put negative 24, 3x minus 2, all over the 6x minus 8 to the 3rd. And that will be my answer. Question.
So enough marks is a 5. Enough work is a
Sir,
5
the
mark.
3x minus 2 all squared. Never see where you do that.
3x minus 2 all squared, 3x minus 2. This one here?
Yes, sir.
I have one 3x minus 2 here, but I want a 3x minus 2 all squared, so that means I need to put back one more here. Remember, I'm factoring out a 3x minus 2, So 3x minus 2 all squares is the same thing as 3x minus 2 times 3x minus 2. Talk truth. Yes, no, talk to me now.
Say it over again.
3x minus 2 all squared is the same thing as 3x minus 2 times 3x minus 2.
Yes, it is, sir.
But the more, look, I have one of them outside here, so I don't need to put two of
Oh,
them. I
you
just going to put
separate them
yeah,
from each other.
yeah, man, yeah, man, yeah, man. I'm done. The topic is finished. I'm finished. What is left now is for you to find questions and just work it, or them. Find questions and work them. The topic finished. I've presented the topic to you. I've shown you how the formulation works. The product rule is the first, times the differentiation of the second, plus the second, times the differentiation of the first. The quotient rule is the denominator, times the differentiation of the numerator, minus the numerator, times the differentiation of the denominator, all over the denominator squares. And when using the chain rule, of course, y equals x to the n, dy by dx is going to be equal to n, x to the n minus 1. And when it is that you're differentiating a power rule, you are going to be differentiating everything as a whole. Reduce the function by 1, reduce the power by 1, and then differentiate inside the parentheses. Those are the 4 rules that you're going to be required to know just now. There are many other rules in it, you know. Trigonometric ratios and, you know, whatever else it is, a logarithmic function that I forgot to teach you, but it's not, no, I'm going to teach you. Guys, hurry up. Time is of the essence. All right? But for now, I've given you survival.
Logarithmic function is the one we have cos and sine and stuff in it?
No, that's the one with that's the trigonometric one. The logarithmic is the one that have ln. The natural ln, yeah, the natural logarithm, yes.
Sir, was something like that in discrete maths?
Yeah, you'll get some of that in discrete maths, yeah.
Also, sir, just wanted to confirm if we'll still be in class sometime next week. You confirm that it will be for Tuesday. We will still be doing class. I said around about 1 o'clock, but about lunchtime. Should we set a time for that? Are we still doing that?
But it's not Tuesday though.
I was just confirming. Any day, any day, we'll work with it. Okay.
Yeah, man, it's Wednesday, man. But confirming for Wednesday. What time is it? You said on Wednesday? 12 o'clock?
Confirm a time.
I don't remember which time. I don't remember which time, sir.
The final, what time was it?
12 is good.
No, 12 is perfect for me, you know.
You just said lunchtime, so you didn't specify a time.
All right, so can we confirm that it's going to be 12 o'clock next week? I mean, Wednesday coming, God's willing?
I'm free Wednesday, sir, so anytime works for me.
All right, so Wednesday at 12, guys.
Okay, I'll make that one.
Yeah, Wednesday at 12, please. I will communicate a room with you. But yeah, we're confirming Wednesday at 12. As I said before, I have no problem with you eating. I won't get a lab because I know you can't eat in the lab. I said if I can get a lecture room. So if you want to carry your lunch, just carry your lunch, and while you're eating, we're still doing some work.
Wait, sir, it's face to face?
Yes, sir.
You can get a link, sir, please, because some of us not able to.
Yes, sir. Face to face for Wednesday.
See, I'm going to come in at PPM schools in Nigeria.
No, not that, sir, but for the distance, I'm have to go move and read school and
okay,
be a challenge, you know.
All right, guess what? So if someone can't make it, I can set up a Zoom link, you know, but guess what? Somebody have a tripod? Somebody have a device where them can just connect to the tripod and then focus it on the board, so at least
Sir,
you.
I thought all this time was a Zoom class that we would have on Wednesday.
Okay,
I didn't know it
fine.
was a face-to-face.
Okay, fine. So you want us all to have a Zoom class on Wednesday at 12 o'clock?
Yes, sir. Please.
Easier for me, sir.
Easier for you. And everybody says Zoom class, we can have a Zoom class at 12.
Anything
Because
else?
that's more convenient
Sir.
for anyone, that's fine.
So Zoom it is then. I thought it was face to face, but it's Zoom. I understand that some of you may come from Timbuktu, and by the time I leave to come there, the class will finish. So Zoom then. But you never hear me say last week when you can't carry no lunch. So what do you think that about?
Sir, I didn't hear that part.
Yeah, I did. I did actually say it though. Okay, no problem. So Zoom is gonna be. All right. All right, let's go. 7:36. I must move. I must move. All right. I must move. I must move. I must move. All right. Alrighty.
Sure, also, did you send the documents the last time? Because we didn't get it.
The last time document, last Thursday. Which document we used the last time? Last time, what we did in class the last time around? Oh, no,
You were
past paper.
supposed to send us some. I think you were supposed to send us some.
I was supposed to send you guys something last time.
Believe so, no, sir. Who do we check? But I believe so. Other guys can confirm it, but I believe so.
Lacarna, did I send anything off to you?
No, sir.
What we did the last class?
Last
So
class,
we did the
sir?
product
Yeah, some
rule.
questions, sir, from the product rule and core rule as well.
Oh,
Yeah,
well,
but
yes.
then the topic was for the product rule, and based on the
Core
last, yes, you showed us
Demo the product rule, and then you did a question that required us to include the power rule in it. So we had to
right, so
power rules first to get the differential, and then product rule.
But you know what happened now? Draft. I have a snap folder that I put all of those something in, and clearly it's not in there. The last thing that I'm seeing for you guys would be past paper questions on first principles and indices and logarithms. I don't see. You know what I have to go do? We have to go just rely on the video for that one. I
sir.
apologize.
That's
Yeah,
fine.
I apologize. Yeah, but
Will you be sending this document?
yeah, man, I'm going to
We'd
be sending
appreciate it
this
if you
one.
send this one.
Yeah, you know what let me do? Let me send this. No,
Quickly.
no, let me not send it. Let me just let me send it there. Last class is which date? The 5th, right? Yeah, the 5th. Mm-mm. Mm-mm. That's the 25th. All right. What was I looking for again? Okay, we're going to a new area. But I thought I opened it though. Yeah, I did. Oh Lord, should I? This is going to take me. All right. right, come. We're going to do this in 20 minutes. We're going to do this in 20 minutes. We'll have to do this in 20 minutes. Where's my share? We'll have to do this in 20 minutes. All right, so having gone through, all right, stretch out the old topic. Make some room for the new topic. If you want to yawn, yawn. Let's go. I'm going to be looking at some applications to differentiation. Now that we know how to differentiate, we're going to look at some applications. So I have some notes here that I want to just have a conversation, kind of lighten it up a little bit, and then we just have one question. I'm going to use these 90 minutes to get to the point where I want to get to, and then leave you for the weekend. And we get through to 10-minute stretch, 10 seconds. All right, let's go. 10 seconds gone. All right. So applications of differentiation. So we're going to be looking at stationary points. And in particular, we're going to look at the single variable function. Again, this topic is going to come to haunt you for Calculus 2. And I think again, for those of you who make it over, because I'm expecting you all to make it over to Calculus 2. So, but for Calculus 2, what we're going to be looking at will be called multi-variable function. Multi-variable function. What we're looking at now is single variable function. Come next semester, whoever you have will be multi-variable function. It means that you can use more than one variable. In this one here, we're going to just use one single variable. All right, get that straight. Now, you're going to have f of x. Remember, I told you already, f of x is equal to y. And if it is that we're differentiating f of x, when you find the first derivative of f of x, it's going to be f dash of x. If we're using y as a function, when you're finding the first derivative, it's going to be dy by dx. If we're using f of x and finding the second derivative, it's going to be f double dash of x. And if we're using y and finding the second derivative, we first find dy by dx, and then we move to dx, d squared y by dx squared. All right, d squared y by dx squared. So that's just some formulation, how it is that we know the stuff. Now, SP is stationary point, as I put up here. So to determine the stationary point, we're going to differentiate the function. You understand why I have to teach the differentiation first? You can differentiate the function. Hear me out. If you get stuck at differentiation, it means you get this question wrong already. Let me just press pause and tell you a secret. You should get 30 marks for a question like this in the exam. Normally, when you go into the exam, stationary point, single variable function, normally you get 30 marks. So if you understand this, and if you don't get 30 marks, you can't get anything less than 20 marks. If you don't get 30 marks for this, you can't get less than 20 marks. But let us use it to say we get 30 marks. You understand this, guys, and you use one question, boom, and get to 30 marks. You're settled. And you know you get the answer right. You are settled. You find the next best question, and you run it off. You must pass the course. Matter of fact, you do this question and get the full 30 out of 30, you pass the course already. All you're trying to do now is just fix up your A in the exam. So we're going to first differentiate the function. You're going to set the differential equals 0. So if you're using the function as f of x, when you differentiate the function, you're going to get f dash of x. You're going to set the differential equals 0. Then you're going to solve for the unknown. Those are going to call critical values. You may not follow what it is that I'm saying, but just listen, because I'm going to give you these notes, you know. Matter of fact, I'm too generous with you guys, you know, but anyhow. If I have it for second semester, when I forgot to start right, because sometimes I feel that you just get the notes and you're not practicing. You're not reading through the notes. Oh, sir, I was busy and so forth and so on. So that's why I'm a little reluctant to send the notes sometime. Last week, I don't know what happened last week. It wasn't intentional. But I'm reconsidering when I generate my notes, all of these here is what I generate to teach my class. And I'm finding it a challenge because when you're not reading them, some of you not read them.
Oh, because I was about to say, no, sir, may I read them?
Yeah, man, some not read them. But anyhow, let's go. So you're gonna set the differential, equals to 0. So f dash of x is going to be equals to 0. You're going to solve for the unknown. And this is when it gives you your critical value or values. It's going to give you a critical value or values. You're going to substitute the critical value or values into the original function f of x. You're going to substitute it into the original function f of x. And then the result together will lead your stationary points or your critical points or your turning points. All of them something they mean the same thing. So sometimes the question will say find the critical points. Sometimes the question may say find the turning points. Sometimes the question will say find the stationary point. Whichever convention them use, you know exactly what I'm talking about. Turning point, critical point, stationary point is the same something. And then you're going to write those critical points, stationary points, turning points in the form x, y, in coordinate form. Then you're going to ask you to classify the nature of the stationary point. You're going to classify it as is it a local maximum or is it a local minimum, right? So you're going to use I highlighted a method 2, but I'm not going to go through the method 2 with you just yet. I'm going to use the method 1. But I'm going to give you the method 2. You can read it on your own. And then I may do a one question showing you the method 2. I find, why I'm not doing the method 2, I find over the years, students prefer the method 1. So method 2 kind of nice to do, but method 1. You're going to use the first differential that you'd have found from up top. And you're going to differentiate it a second time to find the second differential. So you've already found f dash of x. You're going to differentiate f dash of x one more time to find now f double dash of x. To find f double dash of x. When you find f double dash of x, you're going to substitute the critical value or values, your xy coordinate, into f double dash of x. If f double dash of x is greater than 0, then you have a relative minimum. If the value work out to be greater than 0, you're going to have a minimum, a local minimum, a relative minimum, same difference. Local minimum, relative minimum. If f double dash of x is less than 0, you're going to have a relative maximum. And if it equals to 0, you have a saddle point. So if it equals 0, you have a saddle point. If it's greater than 0, you have a relative minimum. If it is less than 0, you have a relative maximum. All right? And then I'm skipping method 2. And then you're going to sketch a graph, but I'm not going to ask you to sketch a graph just yet. No, liar, skip method 2. Okay. Oh, I thought I had done method 2 here. No, I didn't. Okay, no problem. So we're going to determine the intercepts now. So to determine the x-intercept, you're going to substitute y equals 0. And to determine the y-intercept, you substitute x equals 0. Now remember, if the question said to you, find the x-intercept, you can't put x equals 0. Any intercept them asked to find, you have to put the other variable equals 0. So them say find the x-intercept, it is y that you put in equals to 0. And then say to find the y-intercept, it is x that you put in equals to 0. You can't ask to find the x-intercept and you put x equals 0. That don't work. So if them say to you, evaluate the y-intercept, the x-intercept, you can put y equals 0. If them say evaluate the y-intercept, you can put x equals 0. Understood so far?
Yes, sir.
Yes, sir.
All right. And then now, the point of inflection. We're going to use the second differential that we would have already found up top. And we're going to set that equals to 0. We're going to set the second differential equals 0. And then we're going to solve for the value or values of x. Or the unknown could be P2. We're going to substitute and find the values of the unknown. Then we're going to substitute values of the unknown obtained in that one up top into the original function f of x and write down the coordinates. And that is going to be the coordinates of the point of inflection. All of this I'm going to go through again, so you don't have to worry. If you don't catch it now, don't break a leg. So I want you to note something here, that the point of inflection occurs between two critical points at the midpoint. All right? And if the question has just one critical point, then there is no need for the point of inflection. And that makes sense. If the question have only one critical point, there is no way you can have a point of inflection, because the point of inflection occurs between two critical points, stationary point, turning point at the midpoint. So if there's only one stationary point, critical point, turning point, you cannot have a point of inflection. And I'll show you why too. All right, let us look at an example. We have, good timing. Let us look at an example. And I'm going to show you what it is. 3 and 1, 4 and 4, 8. An 8 marker here. It says, and as I said before, a question like this, I'm expecting about a 30 mark for it. You may say to me, then, sir, why this one is 8 marks? Because this is a quadratic equation. Your 30 mark question will be the questions with those functions that are cubic in nature. Cubic means that the highest power in it is raised to the third. Right? So of course, as per usual, I start off very simple and I build on it. So if I say, given that the function y equals x squared minus 6x plus 1, y equals x squared minus 6x plus 1, and we're supposed to evaluate the critical point, the coordinate of the y-intercept, determine if the critical point or points is our maximum or minimum, and to sketch a graph of the function showing all points. The sketch part of something I'm not going to do tonight. So I'm just going to work 1, 2, and 3. Anybody remembers how it is that we find a critical point again? What must we do in order to find a critical point?
About x equals 0.
Before you put x equals 0, we need to do what?
Differentiate the function.
We have to first differentiate the function and then set it equals to 0. Do me a favor. In 1 minute, I want you to differentiate this function, set it equal to 0, and calculate the value of the unknown for me. Differentiate the function, set it equal to 0, and calculate the unknown for me, please. I'm giving you 2 minutes to do all of that.
So x equals 6.
Everybody agrees?
X equal 3, sir.
Which is it, 3 or 6?
I get 3.
It's on this side. Let me see if I might have done something wrong.
Not a problem.
X. Not 2x minus 6.
Sir, 2x minus 6. May I move too fast, sorry.
Oh, no, confuse me for the mathematics for.
Right. Hold on.
Me start with the critical point, but me that remember say, never mind.
So when you differentiate, when you differentiate the function, find dy by dx, what did you get?
2x minus 6,
Yeah,
right?
2x minus 6, sir.
And when you put 2x minus 6 equals 0, what's the value of x?
3, sir. 3.
Everybody agrees?
Yes, sir. That's what I
Yes,
have.
sir. So it's 3.
Agree,
It's 3.
sir.
All right, so I was waiting on you, Tash, to come back. So x is equals to 3. So when I differentiate it, I'm going to get 2x minus 6. Then I'm going to put the 2x minus 6 equals 0. So therefore, I'm going to add 6 to both sides. I'm going to get 2x equals 6. Then I'm dividing both sides by 2 to get x equals 3. Don't worry about what is on the right-hand side. I'll explain that some other time. This is only really for those who did FCM3 with me at whichever point. But everybody agrees with the differential, 2x minus 6, and that when I set it equals to 0, I'm going to get x equals 3.
Yes, sir.
Yes, sir.
Good
Yes,
job.
sir.
Excellent. X equals 3 is my critical value. Is my critical value. In order to find a critical point, I have to now substitute x equals 3 into the original function, y equals all of that. Go ahead and do that for me, please. Substitute x equals 3 into all of what is up top there. Always remember when you're substituting, you are substituting to the original. Always remember that.
That's -8.
Nobody got -8?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good job. So my critical point is 3, -8. 3, -8. My critical point is 3, -8. Very nice. So it then says now, to find the coordinate of the y-intercept, what do I do? To find the y-intercept, what do I do? I just told you.
So is it let x
Sorry, put
equals
X.
0?
Very good.
Equals
Good. When x equals 0, what is the value of y? Look, quick and fast. What's the value of y?
1,
1.
sir. 1.
1. Duh. Very nice. So y is equals to 1. So easy it is. Y equals 1. That's part 2. Part 3 now. Determine if the critical point or points is or are maximum or minimum. Watch me now. I'll do this one with you. Remember, I'm going to find the first derivative.
Sir, when you finish, me go beg you go over because you're going a little too fast for me. You hear me? I'm far behind a little bit. No, finish.
Finish?
Oh, oh.
All right. So the critical point, we need to classify the critical point as whether or not it's a maximum or a minimum. So I have dy by dx is equal to 2x minus 6. So where you get that from? Teach yourself. Up top, when we first differentiated it. But to do the to classify, I'm going to use my critical point, which is 3, -8. And I'm going to find the second derivative of that. Second derivative of 2x minus 6 is going to be 2. Because if this is dy by dx, when I find d squared y by dx squared, I'm differentiating this one more time. That goes to 0. and I'm differentiating 2x, I'm going to get 2. Now, you see this 3 comma negative 8? It means say, anywhere in the second differential, I see x, I put in 3. Is there an x here?
No.
No, because this is a constant. What sign is a constant? Is it a positive or is it a negative?
That's a positive.
And once it's positive, it's a minimum. If it is greater than 0, it's a relative minimum. If it is less than 0, the second derivative, that is, see, second derivative. How do you know that's the second derivative? F double dash. If it is greater than 0, it's a relative minimum. If it is less than 0, it's a relative maximum. If it equals 0, we say saddle point. And that is it. Relative minimum.
So I have some quick points, this one, quick marks, this.
This is some quick 6 marks, yeah, but for the 30-mark question, I am only introducing the topic to you. And if you know what I do, I start small and then build the confidence and then I move into what the level of the question is going to be. So you'll never get a question in an exam which is that is quadratic. The questions that they normally give you, and when you check your past papers, you can see they're all cubic equations or cubic expressions that you're going to have to work out. Right? The function is going to be cubic in nature. All right? So as a quick recap from the question itself, and I'm going to read through the narrative. You get the function, they ask you to calculate the critical point. You get the function, you differentiate the function. When you differentiate the function, you set the differential equals to 0, see it here, so boom. And then you solve for the unknown. The unknown in this case is x, and x going to be equals to 3. This one piece alone, bird can't fly upon one wing, so we call it critical value. Or, yeah, we want critical points, or point, but we just have critical value, piece of something. So what we need to do now is to make it, is to find the other piece, the corresponding y value, by substituting this x equals 3 into the original function. So the original function, y equals x squared minus 6x plus 1. Anywhere in the original function you see x, you put 3. 3 squared minus 6 times 3 plus 1, and that gives you 8. So when you join up the two of them now and marriage them off, you can get 3 comma negative 8. That 3 comma negative 8 is known as my critical point. Then the question asks me to find the y-intercept. No, sir, don't tell me, say themselves y-intercept, and you look for the other one to put equals 0. Say the man want the y-intercept. You go put x equals 0. And anywhere in the function you see x, you put 0. See here, boom, 0 squared minus 6 times 0 plus 1. Answer is 1. So it says a coordinate of the y-intercept. If x equals 0, x come first. So x are front. Y come last. So y they are back. So you can put 0, 1, not the other way around. 0, 1. It did say coordinate. This is in my coordinate form. And then they say to you, determine if it is a maximum or a minimum. Not a problem. We already have dy by dx. We now need to differentiate it one more time. When we find d squared y by dx squared, we're going to get 2. Rock stone. What do you mean by this now, sir? Anywhere is a critical value that you're testing, you know. So you're going to substitute the critical value into the second derivative. Substitute the critical value into the second derivative. See here? F double dash of x. F double dash of x is the second derivative. Differentiated a second time, that's the second derivative. And then when we do that, if the value that we work out gets positive, it's a relative minimum. The value that we substitute and we get negative, it's a relative maximum. If when we substitute we get 0 exactly, it's a saddle point. And that's it. I'm not ready for the sketch yet. Any departing questions?
So you're going to send these notes, right?
Yes, Papa.
Can I read over the weekend?
Yeah, man. Okay.
Run another question, sir. Partner, if you see my go more.
What I'd want you to do is
I'm done.
what I'd want you to do really is just to read over what it is that I've done here with this simple question. And then what I really want you to do is to practice your differentiation, because if you don't understand the difference, if you don't know how to differentiate, all of what we're doing here is nullified. So what I want you to do is to be able to practice your differentiation. Read through what it is that I'm sending you now, what I am going to be sending. I want you to read through it. Don't get me wrong. I want you to read through what it is that I'm going to be sending. But I also want you to practice your differentiation using the different rules, get the past papers and practice it. So once you get a differentiation part, that topic here you can't go wrong with the topic. You really, when I promise you say you cannot go wrong, you cannot go wrong with the topic. I promise you. Any other questions? Talk to me now, guys. If there are no other questions,
So it's not a request for next class.
go ahead.
For the next class, for this topic, I'm going to beg you to go through one more question before you give us one. Next class.
No problem, man. Absolutely. That's what I normally do it, you
Okay.
know. Oopsie daisy. That's what I normally do it, man. Oh Lord. What is his name?
So please remember to send this document off.
If
not this one, not just this one, but the one that we did, the topic that we did before as well.
You're me tell us I can't find the one. You never did.
No, man, I'm saying, remember,
no, man. Hold on. All right,
just
hold on.
touch on SP, the single variable function. So I'm saying what we did prior to that.
Yeah, man. But if you just give me a chance, that's what I'm saying to you. I'm actually copying this stuff as we speak here. So if I sound distracted, that's what I'm doing.
Oh, okay. I see.
Yeah,
I see.
yeah.
Okay,
so I can't send it off. So that's exactly what it is that I'm doing. To send off to you. That's why I was asking if there are any parting questions. Sorry, somebody said something. All right. If what name again, Colonel? Board results. I don't want that. Okay, no, I find it. All right. So the document is now shared with Locarno, and he can subsequently share it with you guys, which includes the review of the differentiation that we did. What's your yeah, I have included both stuff in it. All right, guys, I am going to go. I think I am tired now. I think you are tired too. So have a good one.
Yes, sir.
Much appreciated. Sure, have a good one.
Yeah, man.
Remember, no drinking over the weekend.
It again?
Remember, no drinking over the weekend.
I'll try not to. Later, guys.
Mr. Sham, talk to you after class, after everybody left.
All right, no problem.